For our mini lecture for this week, and before you have your quizam, we are going to talk about moons in our solar system and what I'm just calling debris, which is stuff left over from the formation of our solar system. Here's a sneak peek of some of the things we'll be talking about in this engagement check. We have a beautiful comet here, and this comet is called Comet 153P, and it has the longest known tail of any comet, stretching over 1 billion kilometers. And this is an actual image of a comet. It's called Comet 67P, and it was taken by a spacecraft called the Rosetta spacecraft, which actually caught up with this comet and landed on it and took data of what it's like to be on the surface of an asteroid. I think this picture just looks so beautiful. It's real. It's not an artist's rendition. So here's a little outline of what we're going to talk about as well, and it also shows kind of the hierarchy or different groups of things that we think about when we think about, planetary bodies in our solar system. So we have planets up here, and here we have what we're calling natural satellites. So those are basically just moons, okay? And then we have dwarf planets, like for example, Pluto is a dwarf planet. Smaller solar system bodies down here like comets, centaurs are asteroids. Here's some more of those. And then we have trans-Neptunian objects, which are objects that exist outside the orbit of Neptune. That's the furthest planet away from the sun in our solar system. And then we have Plutoids. Plutoids are essentially Pluto-sized objects that are out at the edges of our solar system. Well, we've already talked about planets, so let's talk about moons. The number of planetary satellites or moons in our solar system changes frequently as we discover more and more. There are more than 150 moons in our solar system. That's a lot. Jupiter has 79 moons. When I say confirmed versus provisional, 53 of those moons are confirmed, which means we know for a fact that they're there. 26 provisional means if it's provisional, that means it has been observed that there's something that's orbiting Jupiter, but we need to take more data and we need to analyze that data a little bit longer in order to really be sure that it is fully a moon. So maybe we might call these moon candidates, okay? Saturn has 82 of these moons plus moon candidates. Uranus has 27 moons. Neptune has 14, Mars has 2, we have 1, and Mercury and Venus are moonless. But even Pluto, which is a dwarf planet, Pluto has moons. Pluto is even smaller than the size of our own moon. So Pluto, smaller than our own moon, also has moons that orbit around it too. So I need to update the slide. Now we say that Jupiter maybe has about 79 moons, okay? And again, this number changes all the time as we discover more and more as we have more time for observations. These here are the 4 innermost moons that orbit around Jupiter. And those are the biggest moons, and those are called the Galilean moons because those are the moons that Galileo saw when he looked through his telescope towards Jupiter. In order from Jupiter, we have Io, Europa, Ganymede, and Callisto. And here's our Earth's moon for comparison, so you can see how they compare in size. Jupiter's innermost moon, Io, is a volcanic moon. It's a volcanic terrestrial moon. What makes it volcanic? What makes it kind of molten inside? Well, that's because of gravitation, incredibly strong gravitational forces between Jupiter and Io, and also the next moon out, Europa, on Io. These gravitational forces are constantly sort of tugging on Io, and that causes a lot of friction, a lot of heat. And then those forces are what's keeping Io so warm, such that its interior is a little bit molten, and you can have volcanic activity on Io. And you can actually see the volcanic plumes on Io's surface. Volcanic plumes, lava flows are always constantly flowing on there. You can actually observe those volcanoes going off on the surface of Io and learn more about Io's acceleration due to gravity, Io's surface gravity, based on how high those volcanoes will erupt on the surface of Io. So here's a picture of a close-up of the surface of Io. We've got these volcanic structures there, constantly spewing lava, constantly filling in cratering events. So you kind of erase any cratering that happens on Io pretty quickly because of that constant flow of lava. The next Galilean moon out from Io is called Europa. Europa has one of the smoothest surfaces of any other celestial body in our solar system. It also has this sort of kind of cracked egg appearance on its surface, or maybe I've also seen people sometimes refer to it as kind of looking like the bottom of an old pot or pan that you might use on the stove. But we think that tidal heating, tidal forces on Europa from Jupiter are enough that it keeps Europa a little bit warm such that ices can melt, and that there's maybe a subsurface ocean on Europa. So here we have a kind of cross-section of Europa. We've got the metallic core of the planet, or of the moon, not the planet, but it's a terrestrial body. We've got the metallic core of Europa, a rocky interior, and above that we think that there's a liquid ocean underneath this layer of ice. So this crust that we're seeing here is an ice layer. And you know, this kind of cracked egg surface look that we're seeing here indicates that maybe there's something like a flow of glaciers on the surface of Europa, similar to how glaciers would flow on the surface of Earth. So when we think about life elsewhere in our solar system, you don't necessarily have to think about being on a planet. It could be on a moon. For example, the moon of Europa. So we're able to have liquid water on Europa because of these strong gravitational forces between Jupiter and Europa, and also a little bit from Io, that are constantly causing that planet to flex a little bit, and that creates a lot of heat. And then that could help to melt some of the ice that would otherwise be frozen. After Io and Europa, we have Ganymede and Callisto to round out our Galilean moons. Ganymede is the largest moon in our solar system. And the surfaces here don't look too much different from that of our own moon. Their surfaces are mostly icy, and they've got some cratering on the surface you can see here too. Callisto might have subsurface liquid water. And we know that Ganymede actually has a magnetic field. And it's the only moon in our solar system that we know about that has a magnetic field. And so that suggests that Ganymede must have some kind of liquid metallic interior that's stirring around to generate that magnetism. The Saturn has the most number of moons of any body in our solar system, of any planet in our solar system. And here are a couple of its largest moons. Here's Titan, the largest of Saturn's moons. And the two others that I think are really interesting are Enceladus and Mimas, or Mimas. And you can see here that it looks a little bit like the Death Star. So Titan is Saturn's largest moon. It is larger than Mercury itself. It has a mostly nitrogen atmosphere, and it is the only body in our solar system other than the Earth where we see surface liquid. Okay, on Titan, this surface liquid is in the form of liquid methane. On Earth, methane is generally present in its gaseous form, but on Titan, you're a little bit further out from the sun. Things are a little bit colder. More things can condense out, and there the temperatures are such that you can have liquid methane oceans or lakes or seas on its surface. So here are some examples of what Titan's surface looks like. There was a probe called the Huygens probe that went to visit Titan. Here we have some pebbles on its surface. Here's examples of those lakes of liquid methane. Titan is also another place we might want to look in our solar system to think about the possibility of life other than here on the Earth. Titan has a carbon-rich chemistry, and we think that it also has an interior ocean, and that is going to make it, again, even more of a high priority target for astrobiology, the study of how life might evolve on other celestial bodies. There's a new mission that has been approved by NASA called Dragonfly. And it's a mission that will go to Titan, and it's a little hovercraft like this. It will land on the surface, collect data, and it will roam around kind of like a little hovercraft to sample different parts of Titan's surface. So that's a really cool thing. It's going to be launched coming up here in about 4 or 5 years. So it takes a while to build these NASA missions. Now, another moon of Saturn that's really interesting is called Enceladus. Enceladus is the 6th largest moon of Saturn, so it's not the largest, Titan's the largest, but it is covered by fresh, clean ice. And we know that Enceladus also has a subsurface liquid water ocean, and it has hydrothermal activity inside it, leading to cryovolcanoes. So instead of volcanoes of lava, it's volcanoes spitting out ice bits and water vapor. Okay, and particularly these cryovolcanoes have been discovered on Enceladus at its south polar region. So in this moon, we have a rocky core, and then above that, a global ocean and an ice crust. And the temperature inside the moon is such that it's warm enough that you can create these hydrothermal vents that spew material out through cracks in Enceladus's surface.